Welcome to the first lecture for Chapter 14, where we look at the ideal gas law and the kinetic theory behind that. So now, most of that is done and covered in chemistry, but now we're going to look at really the physics behind that whole part. And for how that we start this, I'm going to have a guest lecturer today, Miss Carly Galletta now, and she's going to come in and she's going to remind and review how to convert between moles, molecules, and grams. Without further ado, here is Carly Galletta. Thank you very much.
Hello, I'm Carly Galletta. Maybe I know some of you from a few years ago. Anyway, I want to review first the basics of the periodic table. So if you have a periodic table in front of you, great. Hopefully I will soon. But there are some numbers on the periodic table that you will need to know in order to convert. Our goal today is to remind you how to convert from grams through moles to get to molecules. So on the periodic table, there are some numbers, okay? First number is the atomic number. For hydrogen, that's going to be a 1, and that tells you the number of protons. The next number on the periodic table is going to be the molar mass, okay, which for hydrogen is 1.01. Now I want to remind you that this number is the average of the masses of all of the different isotopes of that particular element. So when you're concerned for physics about using the elements on the periodic table, you want to use this molar mass number, the average mass of all of the isotopes. So in order to go from grams to moles to molecules, okay, you need to remember that the mass of 1 mole of any substance is equal to its molar mass on the periodic table. So if you look at your periodic table, if you have, let's pick an element. If you have 1 mole of carbon atoms, okay, if you were to mass 1 mole of carbon atoms on a balance or a scale, they would weigh 12.01 grams. Now, that mass, or 12.01 grams of carbon atoms, is equal to this magic number, which is 6.022 times 10 to the 23rd particles. So any number on the periodic table, those molar masses, what they represent is 6.022 times 10 to the 23rd particles of any element on the periodic table. So this number, 6.022 times 10 to the 23rd particles, is equal to a mole, and it's a quantity, a counting number, like 12 is for a dozen, okay? So you can have a mole of cars, or a mole of Mr. Wolf's, or a mole of Miss Galletta's. We're actually one of a kind, so you can't really have that. But anyway, so we use this number, this mole number, when we want to convert from grams to moles and then to molecules. So I'm going to do an example for you now. Is this good?
This is great. Keep going on.
Okay, just checking. All right, so the example we're going to use today is the question is, question mark. How many molecules are in 52.6 grams of methane? Methane is a gas. Its formula is CH4. So if you're given grams, in order to figure out how many molecules, you have to first figure out how many moles. Okay? So first, we convert grams to moles. Hopefully you remember this. There are a few ways to do this. I'm going to show you the dimensional analysis way. So we always start with what you're given. So you're given your amount in grams. You start with what you're given, and you're going to multiply that by the molar mass found on the periodic table. So I've looked at my table and I've added up the mass of 1 carbon atom and 4 hydrogens, which adds to 16.05, and I'm going to divide my original grams by that because 1 mole of methane has a mass of 16.05 grams. So if you notice, my grams will cancel, and I divide by what's in the bottom, multiply by what's in the top, and what I end up with is 3.28 moles of methane, of CH4. Okay, if I stopped here, you'd have the amount of moles of methane, but the original question asks for how many molecules. So now, we know that in 1 mole of anything, there are 6.02 times 10 to the 23rd particles. Now in this case, a particle is equal to a molecule. If you're talking about individual atoms, the particle would be atom. So in this case, we're talking molecules. So the second and final step is we start with the moles that we found from the first step, so 3.28 moles, and we multiply that by our magic number, 6.02 times 10 to the 23rd, over 1 mole, so our moles cancel, and we end up with 1.97 times 10 to the 24th molecules. Now, if you have a regular sample of molecules, okay, you should end up with a large number here. So it's good number sense to go back and make sure that you check your math and make sure that the number makes sense with what you're talking about. Okay, I think that's it. Are we done?
Do a funny sound off.
No, I don't know what that is. I don't do funny sound offs. Chemistry is cool. You should be taking chemistry right now.